Hi, this is Stephen Brower from Irvine Valley Community College. This is for CSIT 256, Computer Architecture and Assembly Language. This is the overview for Irvine Chapter 2. Portions of this chapter are a repeat of some information that's in Stallings Chapter 1, a little bit in Stallings Chapter 2, and actually some later chapters that we'll get to later in terms of the Stallings. So the earlier parts of this chapter will look at things like the control unit, arithmetic logic unit, the clock, the instruction execution cycle, which is also done in Stallings Chapter 3, how memory is read, and cache. The part on reading from memory has to do with the buses, which we'll see in the Stallings part, but to oversimplify it, the control unit will use the control line to sort of grab the bus, load onto the address lines the address of what it wants from memory. Then it'll set the control lines again, saying, okay, it's ready for the memory. The memory module will realize, oh, it has to do something, fetch the address from the address lines, grab the data from the memory modules, load the data lines, and then set the control line saying that the data is there. And then the CPU, when it sees the data is ready, then it grabs the data off of the data lines. Now, there's different ways in which that synchronization between the CPU and the memory takes place, on whether or not the control lines are set or not, but there's just more of the premise behind it. In Irvine Chapter 2, we'll take a look at different modes of operation that there can be, but we're going to focus on protected mode. In protected mode, and the idea behind it is every application can only address its own memory. And if a process that's running tries to extend beyond what it should, it's not allowed. And so the idea in terms of protecting is that each application is protected from each other. In 32-bit, the maximum amount of memory we can address is 4 gig. It doesn't mean that's how much memory the operating system gives us. Something we'll see, the last chapter we cover is going to be Irvine Chapter 11. We're not going to go in order. And in Irvine Chapter 11, we're going to see using the heap and how we're going to grab, and the demo that I have will grab a gig of RAM from the operating system. I'll have the task manager running, and we'll see that my application then suddenly grabs a gig of memory and then releases the gig of memory. So just because we can address 4 gigabytes doesn't mean we're given 4 gigabytes. Okay. The book covers some other modes of operation, but the protected mode is the one we're going to focus on. The general purpose registers are going to be introduced, and there is an addendum in Canvas, which has sort of some slides that give an overview of the registers. And what I'm going to try to point out here, this is just, again, meant to be an overview that we'll get into the detail later, is that EAX would be a 32-bit register. AX refers to the same register, but the lower 16 bits of those 32 bits. AH and AL refer to the same register, but AH refers to the upper 8 bits of the lower 16 bits. AL refers to the lower 8 bits of the lower 16 bits. So there's one single register that is being referenced, and it can be referenced as 32 bits, 16 bits, or 2 different portions of it can be addressed as 8 bits. If the upper 16 bits has 8 bits that we want to reference, we actually would have to rotate the bits down to the lower 16 bits so that then we can reference or the upper 8 or lower 8 of those lower 16 bits. There are also, and I just saw a major typo down there, there are also some of the registers, although the general purpose registers, some of them have specific meaning. And in the demo that we're going to see sometime this week, is the idea that ECX is used for the loop command in assembly. And so although ECX is a register that we can use for other purposes, if we are using loop, it has to be in ECX. Status flags is something that will be introduced in this chapter. We'll reference how the status flags are updated, but it won't be until chapter 6 where we're going to do conditional jumps based on the status flags, so that if we perform some math and we end up with an overflow, then we can go and handle the overflow situation. The 64-bit general, that's my typo, purpose registers. So RAX is a 64-bit register. EAX is the lower 32 bits of that 64-bit register. And then AX would be the lower 16 bits of that 64-bit register. So we'll see a slide later that does talk about the additional general purpose registers that are available. Yeah, good enough.